For the fun fact, Anthony, did you know that Russia observes the Day of the Programmer every year?
What day is that?
Well, good that you're asking. It is held on the 256th day of the year. So it is on the 13th of September in common years, but on September 12th in leap years.
I like that. That's clever.
Yeah, I think it's one of the few interesting days which is switching days based on leap year or not leap year. But in China, they hold Programmers Day on October 24th because you can write it as 1024.
Okay.
Yeah, that's the fun fact. Welcome to Generally AI, an InfoQ podcast. And today, me, Roland Mertens, is going to talk with Anthony Alford.
Yes, good to be here.
It's the last episode of this season, and we are going to talk about famous programmers. And we are going back from who is currently still relevant, back to foundations of computer science. And I want to talk with you, Anthony, about the Godfather of AI.
Oh.
Do you know who is commonly referred to as the Godfather of AI?
I do not. Or, well, when you say it, I'll go, oh yeah, of course, I'm sure. But
it
tell
is
me.
Geoffrey Hinton.
Of course.
Yeah. So I wanted to talk about Geoffrey Hinton, basically because he pushed ideas of neural networks through and through over the years. And he also really persevered in AI winters. So he wasn't just like a one day, one hit wonder or like a 1 century wonder. He really managed to create amazing contributions to the field of AI over multiple decades.
That AI winter was pretty bad stuff.
Yeah.
I think we have an episode about that.
Yeah, absolutely. I also, by the way, tried to find where the name Godfather of AI comes from and why he scored that. And I tried finding the first reference, but I just can't find it. But in the AI community, everybody seems to agree that this is his nickname. That's what we're sticking with.
He certainly deserves it, I think.
Yes. And in this podcast, it will become clear that this is a name which is rightfully given to him. And the first thing which is interesting about him is that his real interest is not computer science, but rather the question of how the brain works. So when we're talking about famous programmers in these episodes, we often think of people who are really dedicated to the art of programming. And he is more excited about the question of how can we study the brain.
Well, think about that, though. I mean, really, the purpose of computers and programming is to solve some problem. You know, we do tend to get very meta in this community, but ultimately, a lot of people got into computers trying to solve a particular problem.
Yeah, but before AI was a thing, I would always explain it to friends as what can computers learn from humans and what can humans learn from computers. Nowadays, you don't need to explain what AI is anymore. I really got into AI because I liked the in-betweenness, and it seems that he is the same. By the way, he studied experimental psychology in Cambridge in 1970. So that's quite an interesting field of study. And he got a PhD in artificial intelligence from Edinburgh in 1978.
So they were already offering a PhD program in AI back then.
As you can see here, he got one. He managed to get one.
That's great.
I know that in the Netherlands, the study I did, they have been offering studies in AI for over 30 years.
Wow.
But there they renamed a couple of degrees. For example, the study I did used to be called cognitive psychology.
Okay.
And I think by renaming a lot of studies to be called AI, you get a certain sense of this is clearly a field instead of, and these are a couple of people who are doing experimental psychology somewhere.
I think that's pretty good recognition of where the field has come.
No, definitely. The fact that you don't have to explain to people what you're doing, I think is enough recognition on its own. So one of the biggest contributions of Geoffrey Hinton is his paper from 1986 called Learning Representations by Backpropagating Errors. It's a Nature paper. So this is the famous backpropagation algorithm, which we use right now to train large neural networks.
And did he invent that?
So he is actually the second author. So together with two other people, they came up with this. Yeah.
Very cool.
Yeah, that's rightfully a staple of being a godfather of AI. So it's great because now using this backpropagating algorithm, we can learn from a lot of examples and then generalize to an unseen set of examples.
Right.
Actually, that is pretty cool about his persistence is that back in the days, there were really two schools of thought in AI. One is how can we represent things and what are the grammars to learn from it? And the other field, it was more the how can we just learn automatically without having to represent anything? And I think for a very long time, the grammar-based field and the rule-based field was ahead. And now the just learn from examples field is very clearly winning.
Yeah, it's funny. Some colleagues and I were just recently joking about Prolog, which was definitely one of those like a symbolic logic programming language that was a darling of the other branch of AI that you mentioned.
No, indeed, definitely. Something else he worked on, but is not very well known for, are stochastic neighbor embeddings.
Interesting.
Yeah, well, if I say it like this, you probably think I don't know this, right? It's okay to admit it. So he thought of a probabilistic approach to place objects in high-dimensional vectors. And you might know this better from the follow-up paper, which he also co-authored together with a Dutch person, which is called t-SNE.
Really?
Yes. And if I say t-SNE, you of course say yes.
Placing... I say Gesundheit.
Yes, I love probabilistic approaches to place objects in high-dimensional vectors close together. So this is a technique for people who don't know it, it's a technique to visualize high-dimensional data in 2 or 3 dimensions. And these two papers were written in 2002 and 2008, again, well before the big deep learning revolution.
Right.
Another paper I found from him, which I really liked, is his paper on a mixture of experts. So he had an interesting insight in if you have multiple neural networks who are going to be experts on different topics, and you pick the most expert-like one, how can you best get the answer from them and how can you best train them?
And we see mixture of expert networks are, I wouldn't say common, but there's a lot of popularity behind them.
Yeah, some of the big tech companies are now using them, which again wouldn't have been possible if it wasn't for the work of Hinton. So if I say the years like 2002, 2008, I would wager that at this point in time, many people, including me, believed that neural networks were not going anywhere. So
right.
When I followed a neural networks course in 2010, it felt like an old-fashioned thing, which nobody really believed in. Even though I was distributing the training of my networks over like 8 computers in a university.
Really?
Yeah,
nice.
It was still a terrible network. But for most of the world, this would really change in 2012. When a PhD student of him, Ilya Sutskever, and a certain Alex Krzyzewski wrote a neural network to recognize objects in images.
And that would have been AlexNet.
Yes, indeed.
That's very bold to name it after yourself like that.
I really like the boldness. So this network won the ImageNet competition with such a large margin that other labs jumped on the neural networks.
Right.
So in the previous years, the error rates in recognizing these 1,000 categories for the ImageNet competition, they were measuring the top 5 error rates, and that dropped like 2 years before and the year before from 28% to 25%, right? So like, humanity was making progress in recognizing objects. And with AlexNet, it just directly went, bam, 16%.
Wow.
By the way, since then, top one accuracy went from like 58% with AlexNet to now I think the best network has 92%.
So that's remarkable. Now, I know people have their issues with ImageNet, and there are other things like COCO. Just as an aside, do you think object recognition is, maybe we wouldn't call it solved, but it's pretty solved?
I think it's solved enough to kickstart any problem you might have and solve it temporarily. Right. Maybe not at the financial and practical scale you want, but we can know what is. There are still caveats, but it's definitely solved for most practical purposes.
The one that's built into my iPhone, for example, is pretty good. You can do search on your images for dog, mountain, things like that, and that's pretty cool.
No, definitely. For a lot of practical use cases, you might want to have an understanding for what's in an image. Computer vision is fairly easy nowadays, especially if you have access to the ChatGPT API.
Back in the days, in between Hinton's successes there in the AI winter, I remember when computer vision was doing things like finding edges using convolutions and, doing Huff transforms and gosh, I don't even remember what.
I think the XKCD comic on how easy is it to recognize a bird in an image and needing a research lab in 5 years, I think is still
absolutely.
The generation nowadays might not understand this joke anymore. Anyways, AlexNet had 60 million parameters, 650,000 neurons, and had 5 convolutional layers and 3 fully connected layers. And this was a significant milestone which demonstrated the power of deep learning in computer vision. It was also the start of larger data sets. Mm-hmm. So ImageNet, created by Fei-Fei Li, was already amazing because they had like more than 1 million images. But it was also the start of more compute power and thus also larger networks, which can get this generic understanding of the world without overfitting. So when I was preparing this, I was reading all these papers, right? And a really fun snippet I encountered in the AlexNet paper was, our network takes between 5 and 6 days to train on 2-3 gigabyte GPUs. All of our experiments suggest that our results can be improved simply by waiting for faster GPUs and bigger data sets to become available.
And guess what?
Yes, now we are talking about AI scaling laws like there's no tomorrow.
Definitely, that was an anticipation of it. I wonder, probably that's an idea that people have had for a while.
Yeah, it's quite interesting that they already had the insight that simply having more compute and more data would improve things. I think actually that's something which Hinton also says in one of the lectures I've been watching in preparation, that he also always thought, we need more data and more compute, but we also need more innovations. And he's like, we actually mostly just needed more data and more compute.
You're probably familiar with that essay called The Bitter Lesson.
I am familiar.
That's what it is, right? It's just more data, more compute. Don't try to be clever.
It is a bitter lesson. Other things which are interesting in this AlexNet paper is that they talk about using ReLU activation, rectified linear units. So this is yet another invention by Hinton. They also show in the AlexNet paper how much faster their network is able to learn compared to the previous most common activation layer of 10H. Mm. The other thing is that they prevent overfitting using dropout.
Right.
Yet another paper from Hinton, which came out in that year. In other words, at this point in time, the lab of Hinton is absolutely on fire, both because of these large margins towards more classical computer vision methods. So the other options you would have for recognizing things in images were really things like SIFT, like scale invariant features. And other labs basically looked at this and were like, oh, wow, this is way beyond what we can do. So they pivoted towards his approach. Nowadays, as you already mentioned, we keep scaling data, compute, networks. And we are still improving our understanding of the world without overfitting. Also, his research group in Toronto made massive breakthroughs in speech recognition as well. So he's just really going at all the fields at once. And we all know what happened after that competition. All the big tech companies were already looking at his work. So I went through everything on his personal website. And one thing I found funny is that in his grants overview, he just basically said Microsoft kept sending him unsolicited gifts of 10 or 20K. So he just wrote down in like the grants, like unsolicited grant from Microsoft for 20K.
I guess if you could survive winter long enough, it'll just fall into your lap. Huh?
Yeah. Anyways, in 2013, Hinton actually joins Google part-time as a researcher. And notably, he quit Google last year. First of all, fair game. He is now 76 years old. He's still very active as a researcher. But the reason he quit is because he wants to freely express his concerns about the existential threats he's seeing with AI. So I watched a couple of his lectures to figure out what his fear is. And the concerns he has is, do you want to guess concerns?
I do remember reading something, but let's let you tell it.
Yeah, so the first one is, of course, will AI replace our jobs? So intellectual labor is getting better and better. And that's something of all ages, right? But, you know, now, like, we always replaced manual labor with intellectual labor. And now we go from intellectual labor to don't know yet what. And he's more like, this will probably make the rich richer and the poor poorer again. Fakes, other problem. Is it possible to know what is true or not? It is just too easy to generate more content.
I think that's a pretty important concern, actually.
And that's why people have to keep listening to the InfoQ podcast.
Oh, I was going to say, you know, we've already put our voices out there. So if you get a phone call from me in the middle of the night asking for money, it's probably not me.
I will transfer it to you. Other problem is lethal autonomous weapons. You're living in America. You can comment on this.
No, I don't think I want to comment on that. I mean, no matter where you live, I think that's scary.
Yeah, I agree. The last thing is discrimination and bias. But he also had an interesting insight here in that you can maybe solve this problem by showing that your machine learning solution has less bias than the systems you're trying to replace. And the benefit, if you're talking about bias and AI, is that now you can actually measure the bias of a model instead of having to try to measure the bias of a bank employee, like of a person.
Yeah.
By the way, he thinks that AI will be immensely helpful in areas like healthcare, right? So he also sees benefits. He thinks we should continue research. He still thinks that there is a long-term existential threat where super intelligence will basically be used by bad actors for their electorates. If random people go too far, AI may take over. And his other reasoning is that if you have an intelligent agent who can create sub-goals, one of the sub-goals to achieve more is probably get more control. And as long as this super intelligent AI is able to talk to people, it will be able to pursue us as humans. We are too weak to be resistant against the sweet talking of an AI. So yeah, that's his existential fear he has with AI. And he thinks that by not being with a big tech company, he can actively talk about his fears of big tech companies and AI.
That's certainly one of those topics that is guaranteed to be an interesting discussion no matter what. And I always say, personally, I'm not sure how likely this existential threat is from AI, but when someone like Geoff Hinton speaks, I will listen with respect because he obviously knows a lot more about it than I do.
Yeah, I can definitely recommend to listen to some of his lectures. It's definitely a treat. I will put some of my favorite ones in the show notes together with some of my favorite papers. So take a look at the show notes to find those.
So he's no longer with Google. What's he working on now?
I assume he's still working at his research lab in Toronto. I think in 2017, at some point, he came out with capsule networks, which was a more hierarchical approach to knowledge representation. And they didn't really go anywhere, or at least nobody's talking about them anymore. I mean, of course, if you work for that long, you have a lot of ideas which didn't end up being groundbreaking, like Boltzmann machines, I think is one of the things he worked on a lot. Right. Didn't incorporate them into the podcast because, frankly, I don't understand them.
That might be why they didn't go anywhere. That's the fully connected one, right? Where
Yes.
it's like a circle.
Yes, like a circle where between the neurons there's connections to everything. Yeah, anyways, rightfully Godfather of AI, it is Geoffrey Hinton.
Very cool. Thank you, Roland.
Hey folks, have you ever wondered how software leaders pushing the boundaries in today's environment are adopting emerging trends? At QCon San Francisco, November 18 to 22, you will step inside the minds of the engineers who will share how they implement innovations in real-world scenarios. Explore tracks like architectures you've always wondered about, engineering productivity, and, my favorite, generative AI in production and advancements. Here, you can learn from practicing senior software developers on how they are adopting emerging trends. Find out more about the conference at QConSF.com. We hope to see you there.
All right. Well, it's my turn. And you remember last season, I talked about Claude Shannon.
Yes.
And one of the things that I really loved about Claude Shannon was he made multiple groundbreaking contributions to technology, somewhat like Geoff Hinton. And if you think about it, this pattern really ought not be surprising. We're talking about very smart, very talented people. And really, nobody is a one-hit wonder. It's just that I think most people are known for their biggest hit. So here's an example. What is Einstein known for?
Theory of relativity.
Right. But he won a Nobel Prize for his work on photoelectricity.
I did not know that.
That's right. So he did not get a Nobel Prize for relativity. Likewise, Linus Torvalds, he's known for Linux, but most programmers probably also know he invented Git.
Yes.
The source control. Today, we're going to talk about someone else who maybe not everyone has heard of the way that everybody knows Einstein. But he did make several important contributions to computer science, among other things. And in my opinion, he's one of the fascinating intellectual figures of the 20th century. And I'm talking about John von Neumann. So von Neumann was born in Budapest, Hungary in 1903, just a few days after the Wright brothers made their historic first flight. I live in North Carolina, so we take credit for that one.
Everything is before or after the first flight.
Yeah. Von Neumann was very early on recognized as a prodigy. According to Wikipedia, at the age of 6, he could divide 8-digit numbers in his head. He could speak ancient Greek. He could memorize entire books. By the time he was a teenager, he was publishing mathematical papers and making serious contributions to the field. But his father didn't think that studying mathematics was a great career strategy. So he convinced his son to get a practical degree in chemical engineering. So in 1923, von Neumann finished high school. He enrolled in a 2-year Chem A program. But at the same time, he enrolled in a PhD program in mathematics. And he finished them at the same time.
Impressive.
That's pretty impressive. He then did a postdoc year at Göttingen under David Hilbert, and then he became a professor at the University of Berlin. Now, in 1933, he came to America, and he was appointed to a position at Princeton's Institute for Advanced Studies. You may remember that from our episode about Claude Shannon and Alan Turing. Both of them spent a little time there.
Yes.
It's also a familiar setting from a couple of movies. I love to tie pop culture and movies in. So the IAS can be seen in Oppenheimer and A Beautiful Mind.
Yeah. Does von Neumann have a role in Oppenheimer as well or not?
I'm getting to that. Spoiler.
Okay.
The IMDb page for the Oppenheimer movie does not list von Neumann.
Oh, because I think you see him at some point, right?
Maybe, but they don't credit anyone as playing von Neumann. So Oppenheimer movie, of course, is mostly about Robert Oppenheimer and his role at the Manhattan Project. But you may remember there's also a plot line with Robert Downey Jr.'s character, Louis Strauss, where Oppie becomes head of the IAS.
Yeah.
And then A Beautiful Mind is about John Nash. He's an important figure in the development of game theory, which, again, spoiler alert, we're going to talk about in a minute. And that movie is mostly set at the IAS.
Yeah.
And von Neumann's not in that movie either.
Okay.
But he
famously absent from big movies.
It's pretty strange, but he was indeed a part of those stories. So at the IAS, he came in 1933 and he joined the School of Mathematics. And by the way, there's a great book called Turing's Cathedral. It's written by the son of physicist Freeman Dyson. And it talks about some of von Neumann's work there working on computers. I'm getting ahead of myself. Anyway, according to Freeman Dyson, who was also there, he said, the School of Mathematics has a permanent establishment which is divided into three groups, one consisting of pure mathematics, one consisting of theoretical physics, and one consisting of Professor von Neumann. So he was definitely in a class of his own. Now, he had done his graduate work in mathematics. He was making contributions to mathematics, was technically on the faculty of mathematics, but he did so much more. There's a Wikipedia page listing the things named after him. There's more than 70 entries. In the Wikipedia article about him, there are major sections on mathematics, physics, economics, computer science, and defense work.
Okay, so he did a bit of everything.
He did. He was definitely what you might consider a polymath. So in physics and defense work, he worked on the Manhattan Project. He was the leading authority on the shaped charges which were used in the Fat Man bomb. And that's the one we see detonated in the movie.
Yeah.
So talking about existential threats earlier, we've managed to live with nuclear weapons for quite a long time. Hopefully AI will also be controlled. Part of that control, at least in this country, was that nuclear technology was placed under the control of the Atomic Energy Commission. Von Neumann was a member of that. He also worked on our intercontinental ballistic missile program. You know, you may remember in Oppenheimer, the movie Oppenheimer was kind of had some regrets about what they had done. I'm not sure von Neumann did, but if he did, he was going to make sure that at least he was in charge.
Yeah.
But it's his contribution to economics that ties him in with John Nash and A Beautiful Mind. Von Neumann invented game theory in collaboration with an economist named Oscar Morgenstern. They did it as a side project during the war. So in their spare time, they wrote a book called The Theory of Games and Economic Behavior. And this provided a mathematical model of two-player, zero-sum games with perfect information. That covers a lot of games like chess.
Yeah.
Right? So anyway, they also included work on games with imperfect information and games of more than two players. Now, John Nash famously extended the game theory to include cooperative games. That's the famous scene in the movie where he's there in the bar with all the great ideas come to you in the bar. So he was in the bar with the other mathematicians.
I also like how in a world dominated by men, it was still the best way to explain an idea is just by referring to beautiful women. That already is sexist on its own.
But we're talking about famous programmers. And the question is, was von Neumann a programmer? Well, he worked with computing machinery quite a lot during the war, not only on the Manhattan Project, but also on just ballistics and other military projects. He is credited with inventing the merge sort algorithm. So that's programming.
That's interesting. I didn't know that.
Yeah, it's in Donald Knuth's book. He's credited with that. But probably we know von Neumann better as a famous computer hardware designer. So he led the project at the IAS to build a computer. And remember that wiki page list of things named for von Neumann? There's one called the von Neumann Architecture. And this is still the high-level design of most modern computers, which he described in 1945. So the architecture is a processing unit with both an ALU and registers, a control unit that includes instruction register and program counter, memory for storing both data and instructions, and then external storage and I/O. Now, we don't think of it as unusual now, but those early computer devices, the Maniac and ENIAC and things like that, and the computers used during the war, they didn't really have stored programs. The program code was not stored in the machine's memory.
Then where was it stored?
It was hard-coded physically, often with wires or patch cables. So imagine your Moog synthesizer with all these patch cables, doing that to program a computer.
Okay, so each computer would only be like a one-purpose machine.
It could be reprogrammed, but you had to physically reprogram it.
Ah, okay. That sounds like a lot of work if you just want to start Slack.
The idea is kind of similar in the old video game consoles. Only, reprogramming was you swap out a ROM. But the same kind of idea. But with this program stored in memory, that's the crux of the von Neumann architecture. There's a different architecture called the Harvard architecture, which has separate address and data buses for instructions versus data. And tangent, I actually worked with one of those back in the 90s when I was doing digital signal processing. Analog Devices had a DSP chip called the Shark, the Super Harvard architecture. Anyway, I'm getting off the rails here.
But is there still anyone doing different architectures or not?
Probably, but I think it's one of those ideas that pretty much everyone is going with, is like the von Neumann architecture, where data and instructions are just stored in memory, and they're, it's interchangeable. And one of the nice things about that is that now the program is potentially self-modifying.
Yeah.
And so now these things can be considered universal Turing machines. And there's not hard evidence, but most people think that von Neumann was actually aware of Turing's work and that it influenced this design.
Yeah. When did he design his architecture?
He described it in a paper in 1945. The team began working on it at the Institute in 1946. It was not operational until 1951.
Yeah, so this is after Turing already published some ideas, but Turing was working on like other physical machines during the war. Yeah.
More or less at the same time too, I think.
Yeah.
And as they say, the rest is history. I didn't have a lot of time to talk about von Neumann's life outside his work. By all accounts, he was an extremely interesting person, something of a bon vivant, Natalie dressed. He loved music. He loved parties. I mentioned he had a great memory. He could recite entire books. He was particularly fascinated with what we call the Byzantine Empire, the Eastern Roman Empire, which lasted until 1453.
Byzantine or Bayesian?
I can't come up with a good joke for that. You're going to have to let me get back to you on that. Maybe we can edit it in. So von Neumann was certainly unique, but interestingly, he was just one of a remarkable group of about a dozen Hungarian Americans called the Martians. These are mostly mathematicians and physicists. They were pretty much contemporaries. Several of them did appear in the Oppenheimer movie. For example, there was Edward Teller, who helped develop the fusion bomb. There was Leo Szilard, who co-wrote the letter that convinced FDR to launch the Manhattan Project. So they were called the Martians because of the Fermi paradox. Enrico Fermi, another key figure in Oppenheimer, he once posed the question of, why don't we see any evidence of extraterrestrial intelligence? Universe is big. Somewhere there must be some intelligence, something that evolved super intelligence. We should see them by now. And so Szilard joked that, well, we do have them here. They just call themselves Hungarians.
Okay, nice.
Edward Teller, whose initials are actually E.T., when he heard this, he acted very concerned that someone had leaked this secret information.
Okay.
So to sum up, if it ever feels like computers are alien technology, the answer is they are.
You would wonder now that with neural networks, can't you create some architecture where you separately load in the weights and then the data, but then have just the inference part fixed or something like that?
If we want to kind of riff on the Oppenheimer theme, everybody in our community probably knows Richard Feynman.
Yeah.
And in the 80s, he worked briefly at a startup in the Boston area that was making basically hardware neural networks, the connection machines.
Feynman was working on connection machines.
Yeah.
Interesting. Yeah, this guy worked on everything.
We could do a whole podcast series on Feynman, but we don't need to because he's got a book, right?
Yeah. The book is quite good.
Surely you're joking. It's a great, great read. Anyway, I guess I should say there are people who have tried to do hardware patterns that look more like the structure of neural networks to more and less success.
One recommendation, by the way, for people who studied maybe experimental psychology instead of computer science. I really like the book, But How Do It Know? The Basic Principles of Computers for Everyone from J. Clark Scott, which really goes into how do computers load things into memory, how do they process things, etc. So can recommend that.
We'll have to put that in the notes for sure.
Cool. Thank you very much.
A pleasure as always.
All right, words of wisdom. Is there anything you learned in the last couple of weeks which you want to share? A fun fact, something useful?
I didn't learn anything recently, but when you mentioned that the Chinese celebrate Programmers' Day on 10/24, it reminded me of a little thing from an Isaac Asimov mystery. Now, everyone knows Isaac Asimov for science fiction, but he also loved to write mysteries. And in one of his mystery stories, somebody says that Halloween is precisely equal to Christmas.
Yes, because Oct 31 is equal to decimal
25.
Okay. It's one of these jokes which you have to first compute to then really understand.
It's great, though.
It is a fun joke. In terms of fun facts, I have one fun fact which is not related to computers, but it will upset some developers who are working on taxonomy, logic, or rule-based systems. And that is, do you know what a capybara is, this animal?
I do. It's the largest rodent.
The largest rodent. Basically, it's a massive guinea pig, right? So the Vatican has classified capybaras as fish so that Christians could eat them during Lent.
Okay.
Yeah, so the whole story is that during Lent, Christians are not allowed to eat meat from certain animals.
Right.
And clergymen in Venezuela between the 16th and 18th century were like, hey, capybaras are living in the water. They have webbed feet. And apparently they taste like fish. So they sent a request to the Pope, and the Vatican has granted the request in 1784. So if you're ever in South America and you see a capybara, just know that they are classified as a fish by the Vatican.
Well, you know, again, in the 80s, there was supposedly an incident where someone in Ronald Reagan's government declared that ketchup was a vegetable for some government purpose.
I think this is way more recent. I think, wasn't this under the Obama administration or something?
Oh, no. It could very well have happened more than once.
Pizza is a vegetable.
Oh, well, it's also quite likely that it never happened. And it's just one of those stories that you hear. But
I think the White House at some point voted in that pizza should count as a vegetable during school lunches.
Hey, as long as it doesn't have pineapple on it, we're gonna.
Yeah,
we can call it whatever we want.
It's actually funny because you think, okay, this does make sense. Then again, it's the American healthy lifestyle.
Hey.
But they actually explained that if you look at the amount of vitamins in like the tomato sauce, which goes on the pizza, it is actually way healthier than some of the other things which are normally classified as vegetables. So they were like, you know what, it should count towards the vitamin intake we want the children to have.
Why not?
But as I said, this is going to upset the developers working on any rule-based system or logic-based systems.
Oh, man.
Anyways, I think that is the ending of this episode. Thank you very much, everybody, for listening.
It's the end of the season. This was the season finale.
This is the season finale. I hope you enjoyed listening to the entire season. And it was a pleasure to make it with you, Anthony.
Yes, and you as well.
If people are listening and they think, I want to do something, what do I do now? I think the best tip is to share this episode with your friends, hold listening parties, ask them which episode was their favorite, share it with your colleagues, go to the random channel on Slack and say, please listen to this.
And if you're in QCon San Francisco here coming up, come say hi.
Yeah. if you recognize our voice, please do not be shy. So don't think, oh man, don't want to come say hi. Please come say hi. I would love to actually meet people who listen to this.
As would I.
Yeah. Also, for people who don't know how this is recorded, we are sitting in completely different time zones, all alone in our rooms.
You make it sound sad.
It is very sad. QCon is that time of the year when you can finally meet the people you're actually creating the content for, because normally you have no clue who's actually reading what you're producing or listening to what you're producing.
Very true.
Show notes are on InfoQ.com, and thank you very much for listening.
All right, stop the recording.